This time we will look into the animation software more in depth. I'll explain how the animations are calculated in general. Also, we'll look into 3 new in-editor features that I've added: eye positioning, particle generation, and projectile setup. In the end, I'll show 3 new creatures I've implemented and some other things. Okay, I've upgraded the layout of this animation software. Here you see that I've added color coding to the left, and also I've added automatically sorting of the animations, so they automatically are arranged correctly. When I add a new animation, in the beginning I will only have the base pose for each creature, and I gradually add in animation after animation. So the aqua color here is movement related animations. The blue ones is whenever you're in air, jumping or hanging and stuff like that. And then the green for emotes and red for attacking or taking damage. And also I've added the guideline here, so when I start on a new creature, I will forget what animations are required, so this here is a reminder. Also, this works as the what guides the auto sorting to organize the animations. It follows this rule. Now I'll explain how the animation system works. We have this head here that will work as our part. Each animation has multiple parts that together make up the character. There are 3 important values that will change across frames. That is the position, the scaling, and the rotation. And if we take a look at the variables, we have an array that's called part that has 3 indexes: current frame, current part, and 0 and 1 for X and Y. And then we have the value that is stored inside this array. So as current frame changes from 0 to 1, 2, 3, then the value will be different for each frame. And the same goes for width and height, 2, 3, and then rotation 4. Here we have a simplified setup of multiple frames. There are 10 frames, and the position, scaling, and rotation is different for each frame. You can see that if we play the animation, then we get a simple form of animation. This is how we play, is as simple as just adding 1 each frame of the game. We add 1 to this variable. Now this is too choppy. That's what's happening, is we literally are teleporting from one place to another and changing the rotation and scaling as well. So this is not enough. This is not good enough. So what we want to do is we want to split these frames into fractions. So instead of increasing current frame by 1, we increase it by 0.1. That way we get a gradual transition from one frame to the next. The important thing here is that we always have to keep track of what the next frame is. That way we can calculate that the position of the part will be this current frame's position towards the next frame's position based on the fraction of the frame. So we always need to calculate what the fraction of the frame is, and this will always be a value between 0 and 1, no matter what frame we are in. For example, here this is 2.5, but the fraction of that frame will be 0.5. This will be useful then when we set the position. The goal X and goal Y will be the value that we will use to draw the part to the screen. So lerping is simply giving 2 values, the current X and the next X, and then depending on the fraction of that frame, we will gradually move from current X to next X. So if the fraction of frame is 0.5, then we will be in between the current and the next position. Same goes for scaling, gradually moving towards the next frame's scaling from the current scaling. The only difference is in the angles calculation here, because of the angle being it goes up to 360 degrees and then goes back to 0 after that. We cannot use lerp because that will be incorrect. Instead we set the goal angle to the current angle plus the difference between the next angle and the current angle multiplied by the fraction. Yeah, then we get a gradual and smooth animation. Now notice here that the last frame has a bit of a problem. It doesn't have a next frame because there is no frame after that. So this right now just keeps it at the same frame, creating a stop in animation. That leads us into looping. Looping is very simple, and it just makes sure that the next frame, when we are on the last frame, is the first frame again. Yeah, so normally on any frame we calculate the next frame simply by doing the current frame is the next frame is the current frame plus 1. That way we will always know where our goal is, and we will always have a condition running that if we are on the last frame, if the current frame is the last frame, then the next frame will be 0. Great, now we have looping and it's a smooth animation. You can see here that the last frame gradually transitions from the last frame towards the first frame. Now, this gradual repositioning from one frame to the next frame is still choppy. It is not smooth enough. You can still see the jumps. This will work in many cases, but if you really want super smooth animations, then you have to add smoothing. Smoothing is simply having a separate value representing the actual position that will move towards the goal position, or scaling or rotation. So earlier you saw that we set the goal values, and then we have the actual values. That way, when we gradually move from a fraction to the next fraction, the actual values smoothly transition between the small gaps. Then we get super smooth animations, and then yeah, this is how it works. So for example here, the final x is all this final x is the actual value that we will use to draw the part on the screen. So it is always increased by the difference between our goal and our current, multiplied by the smooth multiplier. So this here within the parentheses represent the difference. So we just add the difference multiplied by smooth multiplier. So in other words, we're moving towards the goal, but in a 10% each frame. Yeah, the same goes for the rest. And then increasing the multiplier, you can see here that when I play the animation, it doesn't catch up. The actual frame is moving faster than what the drawing information is being able to catch up with. So increasing the multiplier, that will make it less smooth, but it will make the part actually reach the keyframe positions. So here you see the difference between smoothing multiplier 0.7 and 0.1. 1 would be literally moving towards the goal destination instantly, and then we are back to the previous step that was just moving by the fractions. So yeah, this is great. Now we have smooth animations. Next, Finally, we have the actual animations like idle, walking, and jumping, and we do that by limiting the animation to a couple of frames. We do that by having a starting frame represented by the blue circle and the end frame by the red circle, and we make sure that the animation plays inside those. Here are some values that represent the animation, the name, the starting frame, the end frame, and then the playback speed. Yeah, this way we can split the entire strip of frames that the entire file contains into animations, and easily shift between those animations to play different animations. Yes, so then I just add a lot of scripts that I connect to buttons or key presses, so I easily add frames, add animations, and add parts, and then delete those. And yeah, that's the part that takes most of the time, making the HUD or the UI. And then the calculation, here in the preparation script, I set the goal values based on what we just went over, and then in the apply script I just smoothly transition from our current transformation to the goal position, scaling, and rotation. Override here is just sometimes you need to override some body parts. For example, in the game, the character when he holds up a weapon, then his arm needs to point towards the mouse while the walk animation is playing. Normally when walking, his arm would move back and forward, but when a gun is held, then these parts need to be overwritten. Yeah, then the animation needs to be drawn, and I just loop through all the parts and display the images based on the final result calculated here in apply. Okay, 3 new creatures. These names are just placeholders. This guy has a strengthened skull, so shooting him in the head will not do any damage. You'll have to aim for the legs. He'll fly towards you, attacking with the skull. Then we have the spider-like creature. They will scream towards you and you get stunned. Then there's a slime. And it's always fun to see them battle each other. So about these extra menus, here you see that this is the default. We have some global variables, if a sound should be played or if the character should just be ejected towards a direction, and these are the part variables that I either change with the mouse or change manually here. And then we have the eyes. This is a new menu where I set up the eyes. You see this guy has 5 eyes, so I can reposition them and select their images and so on, and they will follow a specific part. They have to be separate from the actual head, because they need to blink and maybe expand if they are shot, for example. Another menu is the particle menu. So for example, let me just add a particle here. I add the particle, I set the active particle, so this right now is this screech, so let me select another one, an arm. So I spawn 8 arms, and at this position, and then I decrease their size, stop growing. I can add a spin to them. The spin can be randomized. And then yeah, how often they spawn. You can spawn them more often, the interval. You can create a lot of particles. This is a good system, because it's very good that I can create this inside the animation software, making it simpler. And then the last thing is the projectiles. Let me go to the slime. The slime has this is the attack pattern. So you see in its projectile, it spawns 3 projectiles, and there is just a lot of values that I set for it. The direction of the shot, that it should shoot toward target. Right now the target would be the mouse, and I can make it homing, for example. As I shoot, you see they fly, they try to get to the mouse. If I zoom out a little bit, I can set the speed, bouncing times, if they bounce against walls, pierce if they pierce through enemies. And yeah, you can read all these values. There's just so much freedom. So it just becomes much simpler, and I can do a lot of different creatures. Thanks for watching. Hopefully now that I've got some creatures, I can start working on world building, like making villages or terrain props and stuff underground and so on. See you next time.